So when I specify that the axis is positive x direction and the offset is 0.1, that means MathWorks will now understand that port F and whatever is connected to it is zero point 0.1 meters away from port B in the positive x direction. And that's it. So if I connect, and the opposite of that is port B is zero point 0.1 meters away from port F in the negative x direction, and port F and R is connected to the centroid. What's negative 0.1 what's 0.1 meters away in the negative directions of the centroid is the point that we need to pivot it around. So that's done. If I'm quite unclear, please go through what I've said again. Now we'll be needing it to connect it to a Revolute joint. I'll bring it up. Right. So once again, I can make the connections between F and B ports or both B ports. But however, I chose the convention of connecting opposite ports in series. So that's just a convention I follow. It's a hard and fast rule. So I make the connection. Now, upon making the connection, MathWorks will now understand that whatever coordinate system connected to the port F of the revolute joint can rotate only in a motion as specified in the thumbnail of this block with relative to whatever coordinate system that connected to port B. So if I fix the coordinate system connected to port B, then whatever is connected to port F of the revolute joint will just simply rotate around a fixed axis. So that's quite what we want with regards to the simple mechatronic system that we're studying. We have a fixed axis and our should be able to rotate around it. How do I fix port B? I just drag it in and connect it to the world coordinate system. Right, that kind of deals. That's kind of it with regards to mechanical components of the system. We have completed the revolute joint and we have completed the rod. And with regards to the electrical system, we have finished modeling the model. Right. So now comes the hardest part. Working with Simscape multibody blocks and Simscape foundation blocks and electrical blocks in a single system. That's making interfaces between these multiple types of libraries. It sounds hard and may look quite complex, but in essence, what happens during interfacing is kind of what happens in real life. So in real life, the shaft coming out of the motor is coupled to the rod that's connected to it, and upon coupling, the torque generated by the motor is applied through the shaft to the rod, and the angular velocity of the DC angular velocity of the motor should be the same as the angular velocity of the rod. So that's a physical interpretation of the word coupling. Torque applied by the motor is directly applied to the rod, and that they both share the same angular velocity. That's the physical representation. That's also what we'll be using to make the interfaces or to achieve the coupling in SimScape. So I have specified the two principles we'll be using to make the interfacing or the coupling, which is what I have already described. Two principles, one with regards to torque and one with regards to angular velocity or angular position. Doesn't matter, both are quite equal. But I'll make it angular velocity since angular velocity is the actual variable which is known as the across variable. And I hope you remember what true variables and across variables are. We discussed them in lecture 4 or 5, I can't exactly remember, but true variable is something which can be measured by connecting the measuring equipment in series with the components that's generating a true variable. And an across variable is something that you defined as a variable you measure by connecting the measuring equipment in parallel to the components that you're measuring. Okay, so in the electrical domain, current would be the true variable and the across variable would be voltage. And in the mechanical rotational domain, the true variable is torque and the across variable is angular velocity. Can't remember these are given in the chart in lecture 4 or 5, and you can figure out what the true or across variable is based on the domain that you are working in. Okay, so coming back to our interfacing, we'll be using the two principles. We'll be measuring the torque output of the DC motor and applying it to the revolute joint, and we'll be measuring the angular velocity of the revolute joint and applying it to the DC motor. So we need to measure torque. That will be using an ideal torque sensor. Torque is a true variable. To measure a true variable, you need to connect the measuring equipment in series to the component that you are measuring. So if I am to connect it in series with the motor, I can connect it in this orientation, and another orientation option is this. I can connect the R's and C's together and connect the two R's together. What is the correct orientation? And is, first of all, is there a correct orientation? And if so, what is the correct one? Yes, there is a correct orientation, and if you want to figure out the correct orientation, the rule of thumb that you need to follow is make sure that the two internal arrows are pointed in the same direction. There's an internal arrow over here and another internal arrow over here. Connect them so that these two are in the same direction. So now we will measure. We have measured. Now we are capable of measuring ideal uh, capable of measuring torque, and we'll through the T port will obtain that signal and we'll connect that signal to the revolute joint. And now we need to measure